So let's start with section 4.2. Now we're going to do the graph of rational functions. So here is what we need to graph the rational functions. We need to simplify the functions. We need to find the x-intercept and the y-intercept. How are we going to find the x-intercept? By let y equals 0. How are we going to find the y-intercept? By let x equals 0. Then we're going to find the asymptotes, which is 3 types of asymptotes: the vertical, the horizontal, and the slant asymptote. And that's what we're going to do here. We're going to learn how to find the slant asymptote. Then extra points to graph the function if you want to graph the function on paper. But if you check on WebDesign, they're not going to ask you to graph it. They're just going to ask you to choose the right graph. So let's check the first question here. Not this one. Let's check the second one. The second one, they ask you, consider the following. And the first thing here, they ask you to write down the domain. So how to find the domain for a rational function? So I'm gonna start with example 2. So the function is f of x equal 1 over x plus 3. To find the domain for the rational function, we're gonna take the set up the denominator and say not equal to the 0 or equal to the 0. It's up to you, because you're gonna take all numbers except which number is going to make the denominator equal 0. So I'm gonna say x plus 3 equals 0. Then solve this one, minus 3 from both sides. This is cancelled. So x is going to be equal -3. That means my domain is going to be all numbers, all x, all numbers, or we can type it, all numbers except -3. Because if you plug in -3 here, -3 plus 3 is going to be 0. So we can choose all real numbers except x equal 3. All real numbers except x equal -3. That's mean this is to find the domain. You choose all the real numbers except x equal -3. Now to find the x-intercept, how are we going to find the x-intercept? We're gonna let y equal 0. So where is y here? F of the x is the same thing to y. That means 0 is going to be equal 1 over x plus 3. Now I need to solve this one for x to find the x-intercept. So what I'm going to do, I'm going to multiply both sides by the least common denominator. The least common denominator here is x plus 3. So I'm going to multiply 0 times x plus 3 equal 1 over x plus 3 times x plus 3. Cancel these. 0 times any number is going to be 0. That means 0 is going to be equal 1. And this is contradiction. This is the wrong statement because we got 0 equal 1. So there is no x-intercept in this one. They're telling you here, if there is no x-intercept, you're just going to type D and E. So I'm going to type D and E. Does not exist. Now let's find the y-intercept. How to find the y-intercept? By let x equal 0. So to find the y-intercept, here is x-intercept, so you can know. And here is the y-intercept. We're gonna let x equal 0. So I'm gonna plug in x equals 0 here. That means y is going to be 1 over 0 plus 3. then y is going to be equal 1 over 3. This is the y-intercept. To write down this as a point, x is 0 and y equal 1 over 3. Because to find the y-intercept, you're going to let x equals 0. So x equals 0 and the y is going to be 1 over 3. With the x-intercept on this example, we don't have x-intercept, but you're going to let y equals 0. That's why we're going to put y 0 here. So the x-intercept here, you're going to type 0, comma, 1 over 3. Now, the third option, they're telling you find the vertical and horizontal asymptotes. Let's find the vertical and horizontal asymptotes. How are we going to find the vertical asymptote? We're going to set the denominator equal to the 0. So the vertical asymptote here is going to be, we're going to set x plus 3 equals 0. That means x equals negative 3. To find the horizontal asymptote, the exponent on the top is 0. The exponent on the bottom is 1. So 0 less than 1. That's mean the first option. So the horizontal asymptote y equals 0. That's it for this example. We got everything here. So we're going to type the vertical asymptote y equal negative 3 and comma, y I put capital X equal negative 3, comma, and y equal 0. This is the asymptotes. Now let's check which one is going to be the right graph. By locating all this information, there is no x-intercept. That means the graph is never going to intersect with the x-coordinate. And y-intercept, I have this point, and I have vertical and horizontal asymptote. So 1 over 3 is almost 0.3. That's means less than half. Talking about 1 divided by 3, 0.333. So it's less than half. So let's check. Negative 3 as a vertical asymptote. Negative 1, negative 2, negative 3. And you can't see horizontal asymptote. That means the horizontal asymptote here exists. Now let's check the second one. The vertical asymptote is 3. So this graph is wrong. Because the vertical is 3. The vertical is 3. I'm going to cancel this one. The horizontal asymptote, you see, you can't see horizontal asymptote in all of these graphs. That means it's 0. Y equals 0. This could be the right one. Could be the right one. Let's check the x-intercept. The x-intercept here is 0. So the y-intercept, because we don't have x-intercept, 0, 1/3, which is positive. So if you look to this graph, this one, the y-intercept is positive. But if you look to the other graph, is negative. Is negative 1/3. We need to choose the positive one. So this is the right one. That means this is wrong. You're going to choose this one, the right graph. Example 4, we need to find the first thing, the domain. So we have C of Lx. This is example 4. Equal 4x plus 3 over x plus 4. So the first thing, the domain, it's a rational function. So to find the domain, I'm going to take everything here, the denominator on the side, and I say equals 0. Solve this one by -4 from both sides. So x is going to be equal negative 4. So this is the denominator. That means I can choose all numbers except x equal -4. Because when you plug in -4 here, the denominator is going to be 0, and any number divided by 0 is going to be undefined. So all numbers, this is A, all numbers except x equal -4. That's what they're saying. All numbers except x equal -4. So that's what I'm going to do here. Which one? -4. All real numbers x except x equal -4. Now to find the x-intercept, we're going to let y equal 0. So this is B, x-intercept. We're going to let y equals 0. So I'm going to put down 0 here. So 0 is going to be equal 4x plus 3 divided by x plus 4. Now we're going to do the same thing. We're going to multiply by the least common denominator. Our least common denominator is x plus 4. So we're going to multiply by x plus 4. That means 0 times x plus 4 equal 4x plus 3 divided by x plus 4 times x plus 4. Cancel these. So 0 is going to be equal 4x plus 3. Now, next step, we're going to do, we need to solve this one for x. So minus 3 from both sides. Cancel. That's means -3 equal 4x. Then divide by 4. In this case, -3 over 4 is going to be equal x. So this is the x-intercept. To write down as a point, x is -3 over 4, and y is 0. This is the x-intercept. So we're going to type here, x-intercept is -3 over 4 and comma with the 0. To find the y-intercept, we're going to let y-intercept we're going to let x equals 0. That means you're going to plug in 0 instead of each x. So y is going to be equal 4 times 0 plus 3 over 0 plus 4, which is equal 3 over 4. Sorry, as a point is going to be, this is the y, x is 0, and the y is 3 over 4. So we're going to type here 0, comma 3 divided by 4. Now let's find the asymptotes, because the asymptotes is really important to figure out which one is going to be the right graph. So vertical asymptote, we're going to set the denominator equals 0, which is x plus 4 equals 0. That means x is going to be equal -4. The horizontal asymptote, 1 equal 1. The degree here is 1. The degree here is 1. So 1 equal 1. That means the horizontal asymptote y equal the leading coefficient on the top, which is 4. The leading coefficient on the bottom is 1. That means y is going to be equal 4. So now let's look vertical asymptote -4. I'm going to look to these graphs. Vertical asymptote -4. So that's here. So this is -4. That's okay. This is positive 4. So I'm going to cancel this graph. This is positive 4. I'm going to cancel this graph. I'm talking about just the vertical asymptote. You see positive 4, positive 4. Our vertical asymptote is negative 4. Now this is negative 4, and this is also negative 4. So this is right. Let's check the horizontal asymptote y equal 4. Look to this one. The horizontal asymptote is negative 4. So this is wrong. The horizontal asymptote is positive 4. So this is right. Let's check the intercepts. The intercepts, this one and this one. Negative 3 over 4, which is negative 0.75. So here is negative 0.5, negative 0.5 here. This one is the x-intercept, and the y-intercept, this is 1, 1, 2, 3, 4, 5. It's less than 1, in fact, and this one is also less than 1. So this is the right graph, but by just locating the x-intercept and the y-intercept, we can know which one is the right graph. Sorry, the vertical asymptote and horizontal asymptote. So this is important because sometimes you're gonna get two graphs with the right asymptotes. So you're gonna go back and check the x-intercepts and the y-intercept. So let's do example 6, because example 5 the same like example 4. So example 6, our rational function is f of x equal x squared over x squared plus 9. So the first thing we're gonna state the domain. The domain for this example is if you took the denominator and equal to the 0. So I'm gonna say x squared plus 9 equals 0. Solve this one. So x squared is going to be equal negative 9. Take the square root for both sides. There's negative sign here, so x is going to be plus or minus. The negative sign goes out as an I. The square root of 9 is a 3, so negative 3, negative or positive 3i. So this is the x and the domain. That means this is complex number. In this case, my domain is going to be all real numbers. All real numbers. So this is our domain. Now let's check the next part. So I'm just going to choose here all real numbers. X-intercept, we're going to let y equal 0. So this is B. I'm going to find the x-intercept. So let y equal 0. That means here is the y, which is f of x. So 0 equal x squared over x squared plus 9. Now the least common denominator here is x squared plus 9. So I'm going to multiply everything by x squared plus 9. 0 times x squared plus 9 equal x squared over x squared plus 9 times x squared plus 9. Cancel these. 0 times any number is going to be 0. So 0 is going to be equal x squared. In this case, 0 is going to be x. That means the x-intercept is 0 and 0. X is 0 and y is 0. The second one, we're going to find the y-intercept. By let x equals 0. So we're going to plug in x equals 0 here. That means y is going to be 0 squared over 0 plus 9. which is equal 0 over 9, which is equal 0. So y is going to be equal 0. That means the y-intercept is also the point 0, 0. Next, we're going to find the vertical asymptote. Vertical asymptote, we're going to set the denominator equals 0, which is exactly what we did here. That means x squared plus 9 is going to be 0. Then x squared is going to be equal negative 9. Then x is going to be plus or minus 3i. So we can't graph this one. We can't graph x-intercept. So the vertical asymptote, that means there is no vertical asymptote because it's a complex. So no vertical asymptote. The horizontal asymptote is going to be 2 and 2. They are equal. The degree on the top is 2, and the degree on the bottom is also 2. So they are equal. So the horizontal asymptote y is going to be equal. The leading coefficient here is 1. The leading coefficient here is 1. That's mean y is going to be equal 1. So let's check all this information. Can we find that height graph x-intercept is 0, 0, 0, and y-intercept is 0, 0. We just have horizontal asymptote y equal 1. So by looking to these 4 graphs, if you look to these 2 graphs, there is a vertical asymptote. That means I'm not going to choose this one because my vertical asymptote says does not exist. So I can't choose the asymptotes. Let's look to this one and this one. Vertical, there's no vertical asymptote. No vertical asymptote. X-intercept, the horizontal asymptote y equal 1. So here is y equal 1, and here is y equal 1. Both is right. But what about the x-intercept and the y-intercept? This is 1, 0, 0, 1 as a y-intercept. But the y-intercept is 0, 0, and at the same time is the x-intercept. So this one is wrong. This one is the right option. So we're going to choose this one. Click on submit. So we analyzing the graph, which one is the right one by all these information we have. That's it for this example. So let's find the domain. We're going to say x squared minus 25 equals 0. Solve this one. You can say x squared equal 25. Take the square root for both sides. So x is going to be plus or minus 5. That means the domain, I can choose all numbers except the negative 5 and positive 5. So all numbers except plus or minus 5. Now, B, let's find the intercepts. X-intercept, you're going to let y equal 0. So we're going to do the same steps. You're going to let y equal 0. So it's going to be 0 equal x over x squared minus 25. The least common denominator here is x squared minus 25. So we're going to multiply by the least common denominator. Is going to be 0 times x squared minus 25 equal x over x squared minus 25 times x squared minus 25. This is cancelled with this one. 0 times any number is going to be 0. So in this case, the leftover just x equals 0. So x equals 0, y equals 0. This is the the x-intercept. Now the y-intercept, we're going to let x equal 0. X equals 0. So we're going to plug in 0 here, 0. So in this case, it's going to be y equal 0 over 0 minus 25. And then y is going to be equal 0 over negative 25, which is equal 0. So the y-intercept is going to be 0, 0. So the same thing, what we did before, we have x-intercept and y-intercept the same point. Vertical asymptote is going to be, we're going to let the denominator equal 0. So x squared minus 25 equals 0. You can solve it exactly the same thing what we did here, or you can say x minus 5 and x plus 5 equals 0, like difference between two squares. Now x minus 5 equals 0, x plus 5 equals 0. So here is going to be x equal 5 and x equal negative 5. So we have two vertical asymptote, which is the same thing. The vertical asymptote, which is the point the function is undefined in it, which is the same thing here. Because the function is undefined on 5, that means the function is never going to cross when x equals 5, and never going to cross the line when x equals negative 5. Now our horizontal asymptote on this graph is going to be 1, 2. So the degree on the top is 1, the degree on the bottom is 2. That means our horizontal asymptote is going to be 0. So let's check this information and to choose the right graph, because we have here 0, 0, 0, 0, same thing. And we have x equal negative 5, and we have x equal, sorry, y equals 0. X equal 5 and y equal 0. So we have 3 vertical asymptotes. Now let's check which one is the right graph. If you look to these 4 graphs, the first thing, x equal 5 and negative 5. So here is equal negative 5 and here is 5. This is right. Negative 5, there is no x equal 5. So this is the wrong, because we have 2 vertical asymptotes. That means 2 lines. So this is wrong. Here we have 1 line, x equal 5, there is no negative 5, so this is wrong. So this one of this one, these both is satisfied. Y equals 0, here is y equals 0 here, and y equals 0 here, so both is still right. X-intercept, what you going to do in this case? Check the x-intercept here is 0, and the y-intercept is 0. So both here. So is this the right graph, or this is the right graph? In this case, you have to do the extra points to test the graph. So what I'm going to do, x, y. The test point, x, y. We're going to choose points on the graph. Let's choose negative 4, and let's choose 4. If the result is positive when you choose negative 4 and 4, if the y is positive here, that means the graph is going up. So this is the right option. If at this point, if the y is negative, that means this is the right graph. So let's check now. This is the extra points. So negative 4, plug in negative 4 here. So it's going to be negative 4 over negative 4 squared minus 25. I'm not going to care about its decimal numbers. So this one is going to be negative 4 over 16 minus 25. That means it's going to be negative 4 over negative 9, which is positive number, because you're going to cancel the sign. It's going to be 4 over 9. It's positive. That means when x equals negative 4, the y is positive number, so it's going up. Then let's check when x equals 4. When x equals 4, I'm going to plug in 4 here. So it's going to be 4 over 4 squared minus 25 is going to be 4 over 16 minus 25, and it's going to be 4 over negative 9. So the result is going to be negative 4 over 9. That means when x equals 4, the y is negative, so it's going to be goes down. That's why this is the right option. So in this case, when you have the same x-intercept, the same y-intercept, so you have to choose extra points. And it doesn't matter, you see the graphs here. If you choose negative 6, that means you're gonna get negative. And here it's positive, so this is wrong. So any 2 points to check which one is going to be the right graph. So let's go to example 8. Example 8, we have of a t equal t squared minus 9 and t minus 3. To find the domain, I'm going to say t minus 3 equals 0. That means t equals 3. So all numbers except t equal 3. Now, the second one, B, we need to find the x-intercept and the y-intercept. So the x-intercept is going to be we're going to let y equal 0. That means 0 is going to be equal. Before I start doing that, here's the mistakes I did. I have to simplify the function. I have to simplify the function before I'm going to find the x-intercept and the y-intercept. It's not x-intercept here because we're working with the t. So we're going to say the t-intercept and the y-intercept. So before I'm doing that, I'm going to simplify the function because we can simplify it. So f of t equal, I'm going to open 2 parentheses because I can use the difference between 2 squares on the top. So 1t here and 1t here, 3 and 3, plus and minus, and keep this one on the bottom, which is t minus 3. Then these cancel. That means our function is going to be f to the t equal t plus 3. Then we're going to find the x-intercept. This is b. Again, it's t-intercept because our coordinate instead of x is t. So we're going to say the t-intercept, we're going to let y equals 0. So here's the y. So 0 is going to be t plus 3. That means t is going to be equal to negative 3. So the point is going to be negative 3 and 0. Now to find the y-intercept, we're going to let t equal 0. So in this case, we're gonna let t equals 0, so the y is going to be 0 squared minus 9 over, we're gonna plug in here, y, we're going to plug it on the top, because we simplified the function. So y is going to be equal 0 plus 3. That means y is going to be equal to 3. So the point, the t is 0 and the y is 3. So we have two intercepts on this example. Now we need to find the vertical asymptote and horizontal asymptote. So the vertical asymptote, which is this is the c, gonna go back here because I already simplified. There's no denominator here no more. That means no vertical asymptote. Let's check the horizontal asymptote. There is not a fraction anymore. So the horizontal asymptote also no horizontal asymptote. So in this case, this is, first of all, we're going to choose all numbers except t equal 3, except t equal 3, which is this one. And the intercepts, the t-intercept is going to be -3, comma 0. And this one is going to be 0, comma 3. Vertical asymptote is going to be, there is no vertical asymptote, no horizontal asymptote, so you're just going to type D and E. Does not exist. Now we're just going to graph because we have two intercepts. The first one is -3, 0. And we can check which one is going to be the right graph. -3, 0, this one. And 0, 3, this one. So this is the right graph. So we're just going to click on this one and submit by just locating the x-intercept and the y-intercept. And if you look to the graph, it's just a straight line. Example 9. This is really important example. So let's check here. The first thing, we're going to find the domain. And our domain, x equals 0. That means all numbers except the 0. Except the 0. So we're going to choose the first one, all numbers except x equals 0. X-intercept, we're going to do the same thing. This is B. To find the x-intercept, we're going to let y equals 0. So this is the y. That means 0 is going to be equal x squared minus 9, not plus, over x. Now multiply by the least common denominator, which is x. So 0 times x equal x squared minus 9 over x times x. Cancel these. 0 times x is going to be 0 equal x squared minus 9. Solve this one. That's mean 9 equal x squared. Take the square root for both sides. So x is going to be plus or minus 3. That means we have two x-intercept. We have a 3 and 0, and we have -3 and 0. Now let's find the y-intercept. I'm gonna let x equals 0. X equals 0. So I'm going to plug in 0 here. That's mean y is going to be 0 minus 9 over 0. And this is undefined. In this case, there's no y-intercept because this one is going to equal -9 over 0, which is undefined. So there's no y-intercept, just two x-intercept. Let's find the vertical asymptote and horizontal asymptote. This is C. So the vertical asymptote, we're going to set the denominator equals 0, which is x equals 0. This is the vertical asymptote. So on x equals 0, there's a vertical dash 9. Let's check the horizontal asymptote. If you look here, there is no horizontal asymptote because the exponents here are greater than the exponents here. And the 2 greater than 1. So we're going to go back here. If the degree on the top greater than the bottom, no horizontal asymptote, we have a slant asymptote. The slant asymptote, how are we going to find it? We're going to divide. So slant asymptote. How are we going to find the slant asymptote? We're going to divide x squared plus x squared minus 9 divided by x. That's mean we're just going to do, like if you want to do long division, it's fine. So this one is going to be, and the quotient is going to be the slant asymptote. So x squared minus 0x minus 9, the missing term, and here is x. Now x squared divided by x is going to be x. X times x is going to be x squared. So in this case, we're not going to use this one, the 0x. So I'm just going to keep it x minus 9. Change the sign. This one is canceled. So this is the remainder. That's mean, and this one, when I divided h of x over t of x, q of x, which is the quotient, plus the remainder divided by the divisor. This is the rule to do the long division. That's mean h of x divide, it's h of x, it's already rational, so we don't have to write down the division, just h of x. That's mean h of x is going to be the quotient, which is x, the plus the remainder is negative 9 over the divisor, which is x. So this one is the slant asymptote. So when you're done from the division, which is the quotient, is going to be the slant asymptote. That means you're just going to type y equal x. So here is the slant asymptote for this graph. That means if there is slant asymptote with vertical asymptote. So the slant asymptote is the opposite of, is look like opposite of horizontal asymptote. If you have horizontal asymptote, you're not going to get a slant asymptote. But if there's slant asymptote, that means there is no horizontal asymptote. So let's type the x-intercept, which is 3, 0. And be careful, they tell the smaller value. So negative 3, 0. And the large value is a 3, 0. Y-intercept, there is no y-intercept, so D does not exist. And the vertical asymptote is x equals 0. And slant asymptote, we're just going to say y equal x. This means we have a slant asymptote. And if you look to the graph, this is the slant asymptote. This is a slant asymptote. You see, it's not a vertical, not horizontal, it's a slant. Now let's use this information to find which one is the right graph. We have the intercepts is x, these two intercepts, 3 and 0. So let's look here. I have, this is the 3, the graph intersect with this, with x coordinate at the 3s, 1, 2, 3, and negative 3. So this one could be the right one. There is no intersect with the x, so this is wrong. There is no intersect with the x, so this is also wrong. Vertical asymptote, we're not going to do anything with the vertical asymptote. Why? Because it's here on the y coordinate. We can't tell. But y equal x, this is the slant asymptote. How are we going to say this is the right one or this is the right one? In this case, you have to graph this line. How are we going to graph the line? We're going to let x and find the y. So choose 2 or 3 points for the x. Let's choose, because we need to graph this one, -2, 0, and 2. So if I plug in -2 here, the y is going to be -2. If I plug in 0 here, the y is going to be 0. If I plug in 2 here, the y is going to be 2. So we have these points. If you graph these points, you're going to get the slant asymptote. So let's check -2 and 2, which is this is 1, 2. This is 1, 2, and -2, 1, 2. So it's going to be here. 0, 0 is going to be here. 2, 2. So 1, 2, and 1, 2 is going to be here. That's mean this is the right graph because this is our slant asymptote. This is wrong because these points is not going to be a slant asymptote here. So this is our right graph. That's it for this example. Let's do one more. So let's do the same steps on example 11. I'm not going to do example 10 because it's exactly like 9. So example 11 is going to be, first of all, we're going to find the domain. The domain, the same thing. Take the x equals 0. This is all the domain, all numbers except 0. So all except x equals 0. B, we're going to find the x-intercept. We're going to let y equals 0. So y is going to be 0 equals 7x squared plus 2 over x. Now the least common denominator is x. So we're going to multiply by x. So 0 times x equals 7x squared plus 2 over x times x. Now we're going to cancel these. So 0 is going to be equal 7x squared plus 2. I'm going to solve this one. Move the 2. So -2 is going to be equal 7x squared. Then divide by 7. So -2 over 7 equal x squared. When you're taking the square root for both sides, let's write down here, is going to be complex number. -2 over 7 equal x squared. Take the square root for both sides. That's mean is going to be square root of 2 over 7 I equal x, which is a plus or minus, which is complex number. That means there is no x-intercept. No x-intercept. Let's find the y-intercept. The y-intercept, we're going to do the same thing. We're going to let y equal, when it's x equals 0. So the y-intercept, we're going to let x equal 0. That means we're going to put 0 here. So y is going to be equal 7 times 0 squared plus 2 divided by 0. In this case, y is going to be 2 divided by 0, which is undefined. So no y-intercept. Now we're going to find the vertical asymptote. This is C, vertical asymptote, which is set the denominator equals 0, and that's what we got as a vertical asymptote. Next, we're going to find the horizontal asymptote. Check the degree on the top is 2. The degree on the bottom is 1. In this case, there is no horizontal asymptote. We have a slant asymptote. How are we going to find the slant asymptote? We're going to divide. I'm going to divide 7 x squared plus 2 divided by x. 7x squared divided by x is going to be 7x. 7x times x is going to be 7x squared. Change the sign, cancel, and here's the remainder. So that's mean f of x, which is a rational, equal the quotient plus the remainder is 2 over the divisor, which is x. So this is our slant asymptote. That's mean the slant asymptote is going to be y equal 7x. To graph the slant asymptote, you're going to do the same thing. You're going to choose 3 points for x, choose -2, 0, and 2 to find the y. -2, plug in -2 here is going to be -14. Plug in the 0, it's going to be 0. Plug in 2, it's going to be 14. That means we have -2, -14, and we have 0, 0, and we have 2, 14. So here is the 3 points. We can graph it to find the slant asymptote. That means in this case, first of all real numbers except 0. There is no, does not exist x-intercept, does not exist y-intercept. We have only vertical asymptote x equals 0. And we have a slant asymptote, which is y equal 7x. Now let's check which one is going to be the right graph. No x-intercept, no y-intercept. How are we going to figure out which one is the right graph? By checking the slant asymptote. Let's check the slant asymptote. Negative vertical asymptote here, we can't tell which one is the right one. Let's check the slant asymptote, which is -2, -14. I'm going to check this one. -2, which is 1, 2, and -14. This is 5, 10, 15, and 20. So 1, 2, and 14 is here. This is almost the right one. And 0, 0, and 2, 14 is going to be also here, which is here is 15. So here is 14. So it could be this one. This is 100% is wrong because this slant asymptote. And this one is could be the right one because if you check here, this is also 20, and here we have 2 intercepts, x-intercept, but there's no x-intercept. So because we don't have x-intercept, so maybe this one is the right one. So this is 2, 1, 2, and 14 as a slant asymptote. And the same thing here, -2 and -14 as a slant asymptote. So could be this one is the right one, could be this one. So in this case, what I'm going to do, I'm going to choose a point. Let's choose -2. If the result is going to be positive, that means this is the right graph. And choose here -2. If the result is going to be here, this is going to be the right graph. This is just to check. But 100%, this is the right option. Because here we have intercept, and we don't have intercept with this one. Here we go. This is the right graph. Why? Because I told you with this graph, there is intercept on the right asymptote, the slant asymptote, but the graph is wrong because we have intercept and there's no x-intercept with this rational function. Let's move to the last one. So here's the last one. We're gonna do the same thing. The first thing, we're gonna find the domain. So the domain, all numbers. We're gonna take the denominator equals 0. That means x equal 1. So our domain is going to be all real number except x equal 1. Now let's find the x-intercept. We're gonna let y equals 0. That means 0 is going to be equal x squared over x minus 1. The least common denominator here is x minus 1. So we're gonna multiply by x minus 1 equal x squared over x minus 1 times x minus 1. Cancel here. 0 times is going to be 0 equal x squared. That means x is going to be equal 0. So the x-intercept is 0 and y is 0. Y-intercept, you're gonna let x equals 0. That means y is going to be equal 0 divided by 0 minus 1. It's going to be 0. So the y-intercept is 0, 0. So we have x-intercept and y-intercept is the same point. Now let's find the vertical asymptote, which is C. Vertical asymptote, set the denominator equals 0, which is x minus 1 equals 0. That means our vertical asymptote, x equal 1. The degree here is 2. The degree here is 1. So in this case, no horizontal asymptote. We have the slant asymptote. How are we going to find the slant asymptote? By doing the long division. So we're going to divide x squared, and we're going to write down the missing term by x minus 1. So x squared divided by x is going to be x. X times x is going to be x squared. X times -1 is going to be minus x. Change the sign. This is cancel. 0 plus 1 is going to be just x. Bring down the 0. It's not going to change anything. Now x divided by x is going to be 1. 1 times x is going to be x. 1 times -1 is going to be minus 1. Change the sign. This is cancel, so it's going to be 1. That means h of x, which is the rational, is going to be the quotient plus the remainder. Let's write down the rule, because this is a rational. So it's going to be the quotient plus the remainder divided by the divisor. So our h of x is going to be the quotient plus the remainder is 1. The divisor is x minus 1. This is the slant asymptote. So the slant asymptote is going to be y equal x plus 1. To graph it, we're going to do the same thing. X, y, that's the -2, 0, 2. You can choose any numbers. I'm choosing always these three numbers. You can choose -4, -5. It's up to you. So plug in -2 here. So it's going to be x, -2 plus 1 is going to be -1. So the first point, -2, -1. Plug in the 0. 0 plus 1 is going to be 1. So 0 and 1. Plug in 2. 2 plus 1 is going to be 3. So 2 and 3. So here is the 3 points to grab the slant asymptote. So the x-intercept is 0, 0. The y-intercept 0, 0. Vertical asymptote x equals 0. Sorry, x equals 1. And horizontal, there is no horizontal asymptote, but we have a slant asymptote, which is y equal x plus 1. This is our slant asymptote. Then let's check which one is going to be the right graph. We're going to analyze that. The first thing, vertical asymptote. I have vertical asymptote here, x equal 1. This is -1, cancel it. This is also -1, cancel it. I'm talking about vertical asymptote because it's easier to locate. So it could be this one or this one. We have x-intercept and y-intercept is 0, 0. So if you look this one, there's no intercept with the 0, 0. With this one, there's no intercept 2. Which is, oh no, there's intercept with this one or this one. I can't see, there's no intercept with these two graphs. But with the y-intercept, yes, with the point, but not 0, 0. Let's go back to these. X minus 1, x equal 1. Oh, this is x equal 1. This is -1. This is wrong because the vertical asymptote negative. This is positive vertical asymptote. This is negative vertical asymptote. Yes. So this is the wrong one and this is the wrong one because here's positive asymptote and here is positive 1 asymptote as a vertical asymptote. Now, if you look, which one? This one is, there's no x-intercept and y-intercept at the point 0, 0. But this one, yes. There's x-intercept and y-intercept at the point 0, 0. Let's check the slant asymptote. The slant asymptote, -2, -1. That's mean 1, 2, and here is 1. So this is right on the slant asymptote. 0, 1. So here is the 0, and 1 is going to be go up. This is 0, 1. 2, 3. Here is 1, 2. 1, 2, 3. So this is exactly on the slant asymptote. So this is the right one. So we're just gonna submit these. I didn't choose it. There we go. This is the right one. This is the last example on this section.